In this video, we're going to continue our discussion with least squares, regression line, and residuals. Let's take a look at the next example. So use the FICO example from the last section to answer the following questions. Now, before we go any further, remember credit scores can be between 300 and 850. Okay, so part A is determine the least squares regression line. Since the credit score is the explanatory variable, that'll be L1, and the percent interest rate is the response variable, that'll be in the L2 column. So let's put these data values into the calculator now. Okay, so I put the credit score in for L1 and the percent interest rate data values for L2. So where do we go from here? Hit Stat, highlight Calc, and again, we'll go down to Lin Reg AX plus B, which is number 4. Hit Enter. X list is L1, Y list is L2. Highlight Calculate and hit Enter. So again, our slope is the A, so rounding to 3 decimal places, that's negative 0.076. The y-intercept is B, rounding that to 3 decimal places, that'll be 61.369. So let's put this on the paper now. Okay, so the least squares regression line, remember it's y hat, not just y, is equal to negative 0.076x plus 61.369. Okay, part B, predict the percent interest rate if this credit score is 705. So again, x is 705, so plug in. So, multiplying and then adding, that gives me this. Don't forget the unit of measurement, that's percent. Part C, interpret the slope and the y-intercept in the context of this problem. So first off, the slope is, I'm going to write it as negative 0.076 over positive 1. Remember, this is the percent interest. That's the y. And on the bottom, that talks about the credit score. So in general, if your credit score increases by 1, you would expect the percent interest rate to decrease by 0.076%. So I'm going to write this out now. So if your credit score increases by 1, then the percent interest rate will decrease by 0.076%. Okay, the y-intercept, that's 61.369. Remember, as an ordered pair, that would be 0, 61.369. Well, remember, the 0 is the credit score, and the 61.369 is the percent interest rate. The problem is, if you recall, the credit score is going to be in between 300 and 850. So it is impossible to have a credit score of 0, so the y-intercept doesn't apply here. I'm going to write that out now. So the y-intercept doesn't apply here since you cannot have a credit score of 0. So note, you should not use the regression model to make predictions outside the scope of the model. This means you shouldn't use the regression model to make predictions for value of the explanatory variable that are much larger or smaller than those observed. Okay, one other example. Suppose that the least squares regression line between the number of hours studying for a test and your test score is given by this equation. So we want to interpret the slope of the y-intercept. So in our case, the x is going to be the hours, and the y will be, let's call this your test score as a percent. So interpreting the slope, well, the slope here is... Okay. So again, remember, this is the change in y over the change in x. Well, the y here is the test score percentage, and the bottom is hours studying. So if you study for an extra hour, then you would expect your test score to increase by 6.3333%. So let me write that out now. So if your study time increases by 1 hour, then your test score will increase by 6.3333%. Okay, the y-intercept in this case is 53.0298%. As an ordered pair, that's this. So the 0 represents hours studied, and this would be test score as a percentage. So in other words, if you don't study for the test, you would expect to receive about a 53.0298%. So let me write that out now. If you don't study for the test, then you would expect your test score to be a 58.0298%. Okay, that takes care of Part A. Part B, suppose a teacher knows that one student studied for 5 hours and earned an 81% on the test. What is the residual? So here's what we know then for Part B. So it's 5 and 81%. I need to plug in 5 in the least squares regression line. So when you multiply and you add, you get this. So the residual is going to be the observed y minus the predicted y. So we know the person got an 81, the predicted subtract and you get this. Don't forget the unit of measurement. And notice this would be below the average because the residual is negative.